Up next, we have Brian Martin. He's with Sapient Global Markets, and he's actually going to be talking to you about pushing light to the edges and why it probably doesn't matter.
So just a real quick intro. My name's Brian Martin. I work for Sapient Global Markets. It's a consulting company based here in the US in Boston, but we have a global reach, London, India, and otherwise. You might be asking yourself, why the hell is a consultant coming to talk to you about networking? The fact is I spent about 12 years in the trading industry, focused primarily in the networking space, and working primarily for low latency and high frequency trading companies. So this is your one opportunity to hear somebody who's been doing that actually talk about it without the threat of legal repercussion from their employer. In fact, a couple of my employers called me when they found out I was doing this, and they were like, "Can we see your deck before you go? Because we just want to make sure we don't have to sue you later." It's like, okay. So to start, I want to tell you a little short story about the past decade in the trading industry. I'm calling this the Photon Wars. There are three types of trading where low latency or ultra low latency really matters. I'm not going to go into what those types are, but suffice to say they're called arbitrage, scalping, and market making. And in all of those types of trading, the absolute key question that differentiates them, or that not differentiates, but provides them the same playing space, is the first to execute wins, hands down. So if a scalper beats the market makers to the top of the market, they win. If a market maker sets the market faster than an arbitrage shop can go in, they're going to make the money. So there's two ways to win in this space. The first is to be smarter, and the second is to be faster. We're going to talk primarily today about why for the past 10 years, everyone's been focused on faster and not smarter. And then I'm going to end up telling you why we're done with that. Hopefully you guys will get out of this a little bit of a history lesson and a little bit of a, oh, finally, thank God we don't have to deal with that anymore. So I'll add one thing. I call it wars. This is a war. The companies involved treat it like a war. There is espionage. There are millions and millions of dollars being spent in this space on nothing more than getting 1, 2, 3 microseconds faster than your competitors. And I say micro now, knowing that realistically, it's actually nano in many cases. So I want to set the basic scene. I know many of you are telecom, might not have even a fledgling understanding of the trading industry. If you understand this, please don't be insulted. I gave this to a bunch of college students originally, and they definitely needed to understand this. There's a basic cycle of information flow that happens in the trading industry. It starts with an event being published by an exchange. That event travels over a network to a trader or customer who receives the event in their systems, makes some type of decision logic, business logic decision on that event, and decides, okay, I'm going to trade. They then send an execution back over the network to the exchange who receives it. It does some more business logic to match that order with other orders. Replies back, yes, we matched your order to somebody else. You confirmed you sold 100 of this at $29.70. You receive that confirmation as a trader, you put that back into your portfolio, and that affects the decision you may make the next time around, whether to buy or sell. At the same time that the matching logic happens, that actual match itself, and even your choice to execute, becomes an event that gets fed back out to customers and builds this just continuous feedback cycle between the traders, there's multiple people in red, and a single, and I'm saying single, although realistically there's multiple exchanges that are involved here. And the focus over the past 10 years has primarily been, how do we make the stuff in the red circle less? Because of this thing. This was tangible. People could point to this and say, well, I'm far away from the exchange. How do I get closer? How do I reduce the distance? And if latency is simply put distance over velocity, and we know velocity is constant in this case, speed of light doesn't change. Little asterisk after that one, but let's ignore that for now. And what you had was this continuous push to reduce the distance. Many of you are probably familiar with at least the center or the graph in the middle here, what that is. For those who aren't, this is the map of the spread network that runs from Chicago to New York, New Jersey. Folks who have read the book Flash Boys have heard about this network and how it was constructed specifically for the trading industry. Access, just FYI, for those who might not know, access to those circuits was approximately $200,000 plus per month. So pretty significant revenue path to be gained from getting access there. All of the little dots on there, you might or might not realize, are regeneration points or amplification stations all along the path. And we saw this network built specifically to solve the latency question for Chicago to New York trade. New York trade is primarily equities. Chicago trade is primarily futures, options, and derivatives. And there's so much opportunity to trade between those products that this network was created specifically for those three classes of traders between these two locations. New York, New Jersey area, all the blue dots here represent the classic financial data centers out in that area. Again, whole new fiber paths. And this was a little more interesting because we're not talking about long haul paths here, we're talking about short paths. There's a great story about a certain company who tried to pay a homeowner who happens to live on the bluff that overlooks the 300 Boulevard East facility in Weehawken. Because if they couldn't go through that homeowner's property and trench down the bluff, they actually had to go all the way down the street, come around, go over an overpass over the expressway, and come all the way back up. The homeowner fortunately declined, and some sanity was resolved in that space. But that's the level of craziness that started to evolve, that these companies were just paying for feet or meters to be reduced from the fiber paths. How many people of you know Admiral Grace Hopper? Raise your hand. Okay, so Admiral, I'll do a quick bio. Admiral Grace Hopper invented the first compiler working at Harvard. She wrote COBOL. She created the COBOL language at Harvard. She also is famous for her calling down to the maintenance and engineering folks and asking them to please cut off a nanosecond and send it over to her. And their response was to cut off a foot-long section of copper cable and send it to her via interdepartmental envelope. She then became famous for using that as sort of her presentation. She was on Letterman and a couple other places, and she has a very dry and wonderful sense of humor, or she had, bless her soul. But this is how insane it became. That people were companies were having their network engineers go into data center facilities and literally decide to replace 10-foot cables with 6-foot cables to get 4 nanoseconds out of the path. Now, a base logical argument says, sure, if you can reduce that, that's reducing latency. Awesome, it's going to give us a better position. But I want to stop and think about how much money are you going to make with the 4 nanoseconds versus the cost of sending somebody to a data center facility and coordinating the after hours work to swap out all of those cables, not to mention the cost of the cables themselves. Because you already paid for the 10-foot ones and now you're going to replace them with 6-foot ones. I want you to keep that in mind as we come to something a little later in the presentation. But that wasn't the start. My Cisco friends, I apologize. This graph is a little misleading and you guys take the brunt of this, but people started to think, well, why does Cisco need to be the switchgear? Why can't we get better switches? And so Arista comes out right about the time of that big dip you see there in the Cisco market share or the Cisco revenues. Arista steadily grows, but it wasn't just Arista. Voltaire, Brocade, Juniper, everyone started to come up with a separate low latency product line. And firms would replace whole cabinets and cages worth of switches overnight. An anecdote, at 350 Cermak one time, I went down to the loading dock to pick up a shipment. There were 4 pallet loads of Arista switches there. And I was like, wow, that's a lot of Arista switches. And the gentleman from a very large investment bank who had a very large presence at that facility said, yeah, that's just our delivery for this week. We've got another one coming in next week and one more the week after that. That company replaced, just FYI, 138 switches in 3 weekends just to get the extra latency boost of putting Arista in and taking Cisco out. But the fact is a lot of the ideas that have come into the low latency market are old ideas. Cut-through switching. I mean, this is an idea from the origins, and it came back. Why did it come back? Well, why should I have to read the whole header of the packet to decide where to switch it if I can just read the destination and then switch it? Circuit switch topologies. Passive WDM is nothing more than, in most cases, a circuit switch topology from host to host. We went from phone operators that would connect a circuit between 2 points to an IP voice infrastructure that's all packet switched. And now we've got companies trying to get back to, I want to patch A to B and nothing in between. Clos networks. I mean, we saw Clos networks brought up earlier, but the Trill standards from Cisco's Fabric Path and Brocade's VCS, and then Juniper's got their Q Fabric, which goes a little different route. But these are both just examples of that whole collapsing down of that. Little trick here, though. It doesn't really help us in the market data side of things. People focused on this a lot and then realized, well, wait a minute. Our packet sizes are 40 bytes, 60 bytes. Does it really matter? Do we really need cut-through switching if I can read the whole packet into memory in one cycle, make my decision, and route it out? So fortunately, there haven't been whole product replacements based on this, but most of these are add-ons or features of existing products anyways. And then we had a weird problem. CPU utilization on all the trading hosts spiked. And when I say spiked, I mean overnight we replaced Cisco with Arista, and literally overnight, CPUs went from 60% to 80, 90% utilization. And nobody could figure out at first why. Why did all of a sudden my ticker plant become CPU bound? And the answer is that the data that gets shuffled around in most of these hosts is shuffled around by the CPU. When data comes into the network card traditionally triggers an interrupt in the CPU, and the CPU then has to get the data, move it from the network card's buffers into main memory, tell the application has the bus in the system, move it from main memory into the application's memory space so it can access the data. Kernel bypass pops up. Solar flare cards, how many people have solar flare cards deployed in their existing server stuff? I don't know, there's not many people with server gear here, I guess. So solar flare cards came up overnight almost, and again, wholesale replacements. I can't tell you how many trading companies had boxes of Intel 10 gig E cards that would come stock in servers, just dropped at the front of their cage to be thrown out with trash or taken by anybody who wanted them. Because there was just no need at that point. Companies were ordering solar flare cards so fast they couldn't get made. And at one time there was a big delay because a boat could not dock in California because of a strike at a dock in California. And a couple of the executives from some of the trading companies that were waiting for these cards actually called the labor unions and said, listen, if we pay your people a bonus, will you unload this one boat just to get these cards? It's a little bit of the hubris of some of these folks, mind you, but
what did they say?
They said no. Go labor union. CPU group and C groups and CPU set, NUMA memory access. So when the CPU accesses RAM, we want that memory to be local to the core. Because if we don't, we have to go across something called a QPI bridge or local to the bus. And this seems like nothing to go from one core to a memory that's tied to another core. But I'm going to step aside for a second here. Remember when we talked about cutting 1 or 2 or 4 feet of cable off of that? This is how much cable, the equivalent of a bad memory access from one core across a QPI bridge, is equal to. Every time you access memory, which might be 200 or 300 times per packet you're sending on the network, you got a 65 nanosecond penalty if you're not going to the memory that's directly on your correct core. So understanding NUMA memory access in the software is now something network engineers are having to deal with. And they're having to work with the software and the host OS guys to say, oh, Well, the reason your network data is delayed is because you're getting it from the wrong memory bus, or the wrong memory space. And hearing a network engineer say that to a software guy for the first time made me giddy with glee. Because the software guy was like, what? Couldn't understand. Kernel bypass is not a holy grail. I guess this crowd might know who that guy is, but all right, good. CPU set only aligns access. It doesn't change the arrangement of data in memory. And so what it comes down to is that to really fix the software, to use the network correctly, we have to do two things in software. We need to fix the protocol problem. We don't have enough people who really understand how to make and write good software protocols. Binary protocols like SBE and FAST, they allow the data that comes in off the network packet to be memory mapped directly in without having to be converted like XML would have to be converted or any type of ASCII text format would need to be. And we also need data structure intelligence. We need people to understand how the data in the packets is actually structured so that when you get data from software down into the network stack, you don't end up with fragmentation unless you need it. And if you need it, you do it intelligently so you don't end up with a field crossing multiple packets. And then it got really weird. This is verbatim from an email that one gentleman sent to another gentleman at a company I worked at. If I'm building a point-to-point network where my goal is to get a fact in the form of bitwise data from point A to point B, why do I need a switch, a router, or network addressing at all? The market event code in this case for this company became nothing more than sensors. And they literally built a sensor network for market event data. What does that mean? They contacted optics manufacturers and found an optic manufacturer who would let them rewrite the firmware in the optic. They dumped all networking equipment between hosts in one location and another, and they literally passed binary format data from one host to many hosts, not to a single host, but effectively used wavelength multicasting to deliver data on colors from one point to another point to eliminate the switchgear in question. Imagine the scalability nightmare that this created for this company. But it was faster. It eliminated all the network switching, and in fact, it eliminated the entire IP network stack of software code from the kernel. By using kernel bypass, they literally had the application writing into RAM, the RAM and the kernel bypass capability delivering the data straight to the glass transferring the data flows across the glass, and is sucked directly up into user space on the other side. Okay. So case example is basically a company that uses all these things I'm talked about. I'm not going to go into details, but you imagine all these techniques I've talked about, what they did, how they built this network, completely passive metro network in the New York, New Jersey area. So you can imagine every data center in New York, New Jersey connected by flat glass. That glass is split, muxed and split by passive equipment. Every server in their farm had tunable optics that were tunable using their firmware from their software, so they could literally change the wavelength they were sending or receiving on any optic within their trading system code. If you want to listen to a specific, the Qs, for example, QQQ, that was broadcast on wavelength 4917.274. And so if your trading algorithm needed Qs, you subscribe to that wavelength. This is effectively what their network diagram would look like. So there's not a lot there. But could you imagine trying to scale that? Amplification, regeneration, those became things that had to have been done to spread it across some of the distances involved. Carteret to Mahwah is a pretty long haul, all things considered, for a metro area. It works. I can tell you it works. But I can tell you another thing, you don't ever want to touch it. Because if you are, you're chasing a white rabbit. There's so many obstacles to trying to build a solution like this The high cost of implementation. The optics involved here are between $8,000 and $11,000 each. And if you want to put 4 of those in a single server, expand that cost out. It's hard to maintain, it's hard to scale. And I will tell you that the number of people who understand how to build a solution like that, we can count them all on my fingers, not including my toes, and they all know each other, and they all do the same thing for specific companies in this country anyways. So when should an organization think about going down any part of any of these paths? They have to be able to do a real, true cost analysis, benefit sort of study. And companies are not good at that. They either delude themselves into thinking they're going to get more revenue than they're really going to get, or that it won't cost as much as they think it's going to cost. Or both. They forget soft cost almost always. Soft costs are kind of hard to judge, but you also have to have a specific type of IT team to implement anything like this. You have to have network engineers who sit next to the the OS tuning and host tuning people, who sit next to the software developers, who go out for beer every night or every other night and have discussions about, well, if we change the buffer size to this, what is it going to do? It's very hard in such a competitive environment to get the right people together to build a team that can do that kind of thing. In the end, though, distance may still matter. How many of you recognize the bottom of that lake right there? Yeah. So there is a study that a company did about shooting RF or microwave directly from downtown, from Equinix, over to Michigan City, I think it was, to cut off the bottom part of the spread optical network. They wanted to hop in at the, I think it's LaPorte regeneration site. And it would shave 78 microseconds if you could do it. The problem is we all know the weather around here is pretty bad. So it's not going to be a real reliable, open, free space type of path. And that brought about this good when you can get it concept of networking. We'll go back to the thing that we have to have better protocols. They started to develop software protocols that would say, if it comes down the RF path, I'll use it. But if it comes down the optical path and I haven't seen it from RF, well, then I'll use that. But if I've already seen it from the RF path and I get it on the optical path, I just drop it. And they've started to build these types of adaptive algorithms that can decide based on the path and the ingest source of the traffic, which market data to actually use. So the key here is, and this is sort of my going into a little bit of preachy mode, is it's time for companies that are interested in low latency networking to broaden their focus. You cannot solve this with networking alone. We're done. We're past that point. The laws of physics are what they are. These are questions I actually endured people asking in meetings. How can I make light go faster? How much distance could I save if I tunneled through the Earth from Chicago to New York instead of going over the surface of the Earth? We had a geologist in the room when they asked that question specifically to answer that question. And the geologist sat there and looked at the guy and was like, what are you talking about? And the guy gets up and starts to draw a circle on the dry erase board and try and draw the chord line between the... And the best one, though, is this last one. This was asked by an executive, so I'll give him a little leeway for not being in the ground. But he asked when TCP/IP over quantum entanglement was going to be available so that we could just get rid of latency entirely. And I love Ian, so I love this quote from the character Ian Malcolm in Jurassic Park. They spent so much time trying to figure out if they could do something that they never stopped to think whether they should. And that gets us to the whole answer here, is that if you want to do really ultra low latency and low latency networking, you have to take a holistic focus. You have to look at your situation. We know how to be faster. We need to learn how to be smarter with our execution. Do I engage in the market or not? Do I pull back? Do I say, yeah, this looks good, but 10 seconds ago we saw this, so I think this is a feint. I think this is somebody trying to load up the market, and then just as I go to execute, they're going to dump all those trades away, and I'm going to get left high and dry. So in setting the scene originally, we said our focus was here. Now we need our focus to be here. The network has shrunk as far as we can go. We need to focus on this. This week, in fact, last night, Martin Thompson gave a talk at Optiver here in Chicago about the AERON, A-E-R-O-N messaging protocol, which is a new open source messaging protocol that was paid for and developed by an unknown or an unnamed local to Chicago large exchange. I'll leave it at that. They've asked to have this protocol built and open sourced completely to get this messaging piece out of people's heads so that people can get back to trading based on business knowledge and understanding the markets as opposed to understanding everything that's between somebody who's trying to buy and somebody who's trying to sell. So this is my new mantra for all network engineers. If you don't deal with low latency trading, you can ignore this because you have other things you got to worry about, but I'll leave it at this. You have to understand the protocols you're implementing. You can't just use them. You have to not blindly apply commands. You have to help the self-wire developers and the OS people tune the entire stack up and down. They don't understand packet sizes. They don't understand what an MTU means. You have to help them. You have to push back, and I punish executives for this regularly. Push back when they come in and say, we got to be faster. No, we got to be smarter. If being smarter means let's be faster, fine. But answer the smarter question first before we just blindly go down this road of trying to be faster. And I shouldn't have to say this, but encourage those solutions which meet economic and physics reality. Like science reality is what it is. Please don't try and break that. And get advantage through solving the problem holistically. Don't just go one group and say, you guys fix the problem. Everybody has to fix the problem together if you want to play in that space. That's it. Thank you very much for your time, and questions, by all means.
I'll start with a sarcastic comment. You have to take away the HFT's knives so they can't kill their mothers for a microsecond.
Please, let's take them out of their hands.
Yes.
Yes. And that's a regulatory and politics question at this point. There's no business way to get them out. It's been tried. Unless you're willing to play the HFT games back at them, which is just not, that's like fighting fire with fire. No, you fight fire by taking away oxygen, taking away fuel, or taking away the original heat source.
Yeah, sorry, I used to work for White Tower, enough said.
Enough said, yep.
But did anything that you came up with when you're doing this deal with the equalization inside public facilities? To
No.
set a level playing ground?
No. There is not one, I'll take that back. There are a few firms that have a more community and social focus on trying to create a real level market space so that business knowledge drives profit and revenue as opposed to technological capacity. Those few firms are almost always market makers, because the market makers are the ones who get sucked in by the HFT scalpers in almost every scenario. And they're the same ones that are tasked with, in our fiscal system, trying to have an ideal market, the ideal market hypothesis, basically. They're the ones who are there to hopefully keep that in check and keep that in line.
Thank you.
Yeah, pleasure.
More questions?
Are there any examples of technology that is developed from high frequency trading that trickle out to the rest of the network that other industries use?
It's a very good question. I would say I have not seen anything new. There is definitely innovation that would otherwise not have been funded if it wasn't for some company saying, I'm going to invest these millions of dollars. But I mean, like we've talked about, even kernel bypass. I mean, you think about kernel bypass, which to most people showed up with solar flare cards and open onload. It actually came out in 1997. Intel and other companies created that concept, and it's now the DDIO that's part of the new modern Intel chipset, it's just there. But it sat there for so long and nobody was paying attention to it. So something like that where the trading industry brought this and said, hey, this is valuable again. Or where they've said, we need to innovate in this way, RF and microwave. I was talking with a couple gentlemen earlier that the RF and microwave focus that exists now, that's being driven a lot by the latency on the trading side, the latency players on the trading side, let's just hope that when they get to that limit of physics, that some of what's been gained and learned in terms of how to build these wireless networks gets that internet access out to rural communities, helps us build third world countries that don't have the ability to deploy an optical infrastructure that's safe and secure. Or in countries where there's conflict, where you don't want to build a centralized optical network, but you want people to have access to the internet in a larger sense, but more importantly, communication channels. That wireless knowledge and that wireless understanding is absolutely vital to be able to build those types of solutions. So hopefully some good comes out of the investment that the trading industry has made through this.
Not a question, but a comment. I've known a lot of geologists, both in industry and in academics, and I haven't known one that was sober.
Probably a good point. This one came from a university, so I think he had to be sober when he showed up at our office, mainly because we bought him lunch. But we also bought him beer afterwards, so he was probably in that delayed gratification phase.
This is less of a technical question, but I'm always curious about these magical realms where software and sysadmins and network people work harmoniously. So was there some secret as to getting these folks to work together?
Hydroxy group liquid supplication. I don't know. So I in the past 12 years, I've been at 6 different trading companies for various periods of time. And I've seen examples of where they work well together and where they don't. The only thing I can say consistently is that it takes people who have a passion for what is going on. They don't need to necessarily have the skills. A large amount of the knowledge that these people use to do this and do it well is public domain. It's out there because of funded research. It's out there because other people have created it and put it out there. But they have to have a passion to go out and find that information and make the connections between, if we increase this buffer size here, that's going to have an effect for you. And have the other person say, if that has that effect for me, then it's going to have this effect further up the chain. I will tell you that I personally would rather hire somebody who is more passionate about learning and understanding than specifically somebody who already has, I already know everything about that. And that is where I've seen the most success, is where companies hire based on that premise and build teams based on that premise. The other thing I would say is it's an absolute fail if you don't let the systems and the software developers interview the networking guys and vice versa to each of those other sections. Because you will end up getting somebody who knows a lot of networking but just knows nothing about those pieces, and you have to at least know a little to work with them. Cool. Thank you.